Please welcome Scott Dudley to talk about supercharging our server's front-end apps.
Thank you. Hi, everyone. So I'm Scott Dudley from Cenote, as Neil said. I've been building apps in the ecosystem for the last 9 years, and sometimes I feel like my job is convincing the Atlassian host app to do things it wasn't really designed to do, which leads us to today's talk. So we're going to be talking about a number of things that aren't trivial to fit into a server app, and my cat. What are we talking about today? Atlassian has announced that React and Atlaskit are the future for server and data center development. So what are Atlaskit and React? As you may have heard in previous sessions, Atlaskit is Atlassian's UI component library that implements the Atlassian design guidelines. And React is a JavaScript front-end library. If you have an existing P2 or plugins to server application and you want to work with Atlaskit and React, but you're not sure how, then this talk is for you. This assumes some familiarity with plugins to basics. This also focuses on how to get your P2 app to render React components, covering configuration, type JavaScript, how to hook it all up, and some opinions on the tools that you should be using to do this. Information on actually using React itself and going that further level is out of the scope of the presentation, but telling you how to get there and render your first component is what we're going to discuss. So I started my journey as a software developer as a back-end person, and have been slowly drifting towards the center. And I would like to be full stack. I've been dabbling. If you asked me a couple of years ago, what does a front-end developer look like? Well, let's take that left-hand circle and zoom in. There's a mismatch of untyped language features, prototype inheritance, errors that you find more often in the browser than you actually do during your build process, velocity, soy, Xwork. There's a lot not to like. And on the front end, AUI, or the AUI library, is supported for now, but it will probably start fading away as Atlassian pushes more towards Atlaskit itself. So with the latest advances in front-end technologies, let's talk about how we can write JavaScript in a way to merge those two circles back together. Moving to Atlaskit, what does that mean? So if you're writing in Atlaskit, that means you need to be using React. And to be using React, you need to be using ECMAScript 2015 or later. Technically, you don't need to, but writing JSX, you can't do that without it, and it's nearly unreadable if you try. So none of this is easy to set up with the out-of-the-box plugins to set up. Plus, you have legacy code that you need to work with. There's no official instructions yet from Atlassian on how we do this, and references are scattered in various places. So why are we moving to Atlaskit and React? Is it just because Atlassian says we should do it? As it turns out, there are plenty of other good reasons to make the move as well. So first of all, cloud and server reuse is one great reason. You can use the same code base as you may have heard Charles talk about earlier today. Next, you can keep your developers happy. So it's a lot easier to hire people when you're working with modern technology. In addition, you can get faster turnaround of features. And lastly, all the benefits of React itself. So you can replace CSS with self-contained styled components, for example. You can free yourself from the tyranny of AUI host product updates. When Jira 7 goes to Jira 8 and they change everything, you don't care because you're not reliant on their CSS anyway. In addition, you should be using type JavaScript. You may not know it yet, but when you're moving to React, you're going to start using prop types anyway, which are runtime type checking. The time is ripe. As long as you're going there, you should make the switch at build time as well. And with all these technologies, I think we have a way to move those diagrams, those Venn diagrams back together. Another question might be, where can I use Atlaskit and React today? The problem is that React likes to control the DOM. Unfortunately, so do most Atlassian host applications. And this leads to a couple of places where we can use it and some where it's not advisable. So, full steam ahead. If you have a standalone page, you're running your configuration options, or an iframe, you can do whatever you want there. Great, green light. Places where you can proceed with caution, shared pages, things like web panels on other people's pages. You need to stay in your web panel and look out for re-rendering events from the host application. Skating on thin ice, things that are dynamically rendered. For example, Confluence editor macros, probably issue fields on the Jira issue view page, things like that. These get re-rendered dynamically. You need to wait for Atlassian's guidance in that regard. In addition, legacy code. You want to use Atlaskit in P2, but you've got legacy. If you're shipping an app in production with no legacy code, raise your hand. I didn't think so. So all of our products have legacy code, And some products, including some that I've shipped, have more legacy code than seems to be in my basement. And for example, my cat broke into the basement the other day and came out looking like this. If your code looks like that, we'll talk about how to deal with it. What we'll do is divide and conquer. We're going to teach your old dog host application some new tricks, and in some places, it might seem like we're teaching my cat new tricks as well, and you can imagine how well that turns out. You might want to take a picture of this slide. These are some resources we'll be talking about today, including a demonstration plugin that you can pull down. This is MIT licensed. This creates a dedicated Dev Day 2019 page within a Confluence app, showcases a number of Atlaskit components, as well as embedded CSS and images, demonstrations of invoking legacy code, and more. So this is, in fact, a Confluence plugin, but the concepts are broadly applicable to other platforms on Atlassian host apps. We're also I'll be referring to a couple of previous presentations that were done at Atlas Camps, including in Atlas Camp 2017, Krista Roach had server add-ons for front-end developers. In Atlas Camp 18, Tim Sebastian had fast, performant, and high-quality front-end development for Jira Server. And there's a couple of references to the WRM Webpack plugin, as well as Atlaskit itself. Let's talk about next, what's the build process? How do we move on? How do we hook it all up? To render a single standalone page on Confluence with React components, we need all of the following. The first thing is a menu item. And all of these snippets are in your Atlassian plugin.xml. If you've, in fact, done P2 plugins before, you're probably familiar with this. So this creates a menu item that redirects people to the URL admin devday2019.action. Next, we need xwork, or a different routing mechanism on a different product other than Confluence. This handles URL routing. And concentrating on the text highlighted in yellow, what we have is, when we see references to admin/devday2019.action, this causes the server to invoke the devDayAction class, and then it renders our admin page.vm velocity template. Simple enough. Let's look at the next action class. We have devDayAction. This class does absolutely nothing, but we need it to keep xwork happy. Make sure to give it a unique name, especially on some host products that have issues with duplicated names. In addition, friends don't let friends use velocity. This is personal opinion. I think it's a gateway to soy templates. That's another story. We still need one hit of velocity to get our product going, even though we're not going to render any UI with it whatsoever. So what does this do? We need it to render the surrounding app Chrome using site mesh. So we've got some tags at the top that do magic within the host app itself. In addition, we use a require resource to pull in the appropriate JavaScript named Webpack admin resources. And that's something we'll discuss next. You could also do a require context here if that suits your application. From there, we display a base mount point in the DOM where React will mount itself. And this is the div class React mount. If you're using iframes, this is also where you do that. The key here is to make sure that that class name is unique to your app. The next step is you write your code in Webpack. We're going to create a Webpacked JavaScript bundle that will go into a web resource in your plugin XML. It'll be called Webpack admin resources as the key. This bundle will encompass all of the JavaScript, plus includes for React, Atlaskit, and more. You notice there's no screenshot of code here, and that's because we're not writing that code ourselves. This is dynamically generated by the Web Resource Manager Webpack plugin, although you can technically roll your own if needed, and we'll look at this in a little bit. After all that, we're just rendering a single page. You might ask, isn't there an easier way? Wouldn't it be nice if Atlassian had a distinct module type where you could just specify the URL, the JavaScript resource, and have it do all this dynamically? Something like this, for example. Well, unfortunately, this doesn't exist. I said there would be opinion here. So the front-end team is aware of this, and they're thinking about ways of how they can address this in the future. Moving on, one other way to do this could be through a web panel. This allows you to dump a static string from your plugin XML straight into a page. The only catch is you need to get your JavaScript resource deployed to that page. You can do that by making sure it's inserted in the right context. You might want to look at dynamically loading the JavaScript code at runtime only if your mount point exists to avoid bloating page size. There's information in the Atlas Camp 2018 presentation about how to do that as well. Going forward, I also mentioned you should be using typed JavaScript. So with React, you'll be using prop types, which is dynamic runtime type checking. I think you need to be doing static type checking at build time as well. And why? Well, benefits are, one, at build time, you want to detect your errors rather than in the browser or in your tests. Second, it's easier to refactor. You get better code completion in your IDE and the possibility to do some automatic refactoring. And there's a lot of different error types that you can actually catch within your build process or even in your IDE, such as things that are null or undefined that shouldn't be, missing properties in objects, and things like that. And the best part is that when you find an error like that, like, ooh, this wasn't supposed to be null, but it is, let me change the type, then that change is propagated in the type, and everywhere else you use the type, you can say, oh, we need to check for null here, for example. So the two leading solutions for typed JavaScript are Flow and TypeScript. You need to choose a side. Both products provide a similar set of features. Flow is great because when it came out, you could incrementally roll your code base over to Flow. You didn't have to move everything at once. This is actually now possible with Babel 7 and TypeScript as well. Atlassian is predominantly using Flow within Atlaskit itself. So that means that there's a lot of existing types defined for their components. On the other hand, I've heard that they're moving more new code to TypeScript. TypeScript has a bigger user community, but Facebook also sponsors React and Jest itself, so it's more tightly integrated with that ecosystem. At the end of the day, you can decide which of the two you like better and which most fits your use case. What technology do we need in our build system to make all of this work? There are a bunch of pieces, and they're not placed in a nice list somewhere. So let's look at these. The first thing you need is the Maven front-end plugin. What does this do? This installs Node, and it allows you to use npm commands within your build process. Next, you need to be using ECMAScript modules and a package manager of your choice. This lets you modularize components with imports, and this is great because you can edit code and add JavaScript, and you don't need to add new web resources for every JS file you add. You also need to be using Flow or TypeScript, which we spoke about. All new code will be type checked. Legacy code, we'll talk about how to call that as well. Next, you want to be using Babel. Babel is your JavaScript transpiler that will take modern ES 2015 or later and compile it down to something that existing shipping browsers can actually understand. It also allows you to use JSX markup with React, for example. We'll also be using Gulp. So we can't migrate all of our existing code at once. The existing AMPS plugin architecture uses a number of components like YUI, it does minification. We're going to use Gulp as a replacement for all of this and all of your existing legacy JavaScript. And we'll run ESLint, we'll run Terser, but we can also use Flow with that as well if we want, or even TypeScript too. We also need Webpack. This will take all of your legacy code, all of your new code, bundle that up into bundles, and also include Atlaskit, React, and any other libraries that you may be including. Last but not least is the Atlassian Web Resource Manager, Webpack Resource Manager plugin. This will help generate fragments of plugin XML specific to the entry points that are in your Webpack code. Continuing, what does this structure look like in the demo plugin? We're going to segregate our JavaScript code into two different locations. First, our legacy JavaScript stays in source main resources.js. This is processed by AMPS and Gulp that I spoke about. We're going to put all of our new code in source main front end. This is all processed by Webpack. In addition to that, we need to remove the YUI compressor, and we'll look at that next, and that only applies to legacy code. So YUI is the JavaScript parser and minifier that's included by default in a plugin's to build process. YUI has bad error messages, even worse error localization. It doesn't understand ES 2015, so it has to go. What we're doing here is we're saying everything in the source main resources.js directory, we're not actually going to filter it off. So we're going to handle the copying of all those files with our own Gulp task, and YUI, don't touch it. To do this, we're going to add, as I mentioned before, our Maven front-end plugin to the plugin XML. This will install Node, as well as install all of your npm packages on the initial build. Subsequent to that, when you're running Atlas Maven package or Atlas Maven deploy, you get an all-in-one build process. So it will get all of your modules and run everything for you. We're using, in that process, Gulp to process legacy and Webpack code. And we're using a number of individual tasks to make that work, which we'll look at in a little bit. During development, as you're modifying JavaScript code, you'll be using npm run watch. And this uses quick reload, as discussed in the Atlaskit 2017 presentation, to automatically pick up changes without having to do a plugin jar reload. What does it actually look like? This is looking at our gulp file. You'll see that we're actually running a number of tasks in parallel. So we're simultaneously compiling and or watching both our Webpack and our non-Webpack code. And you'll see it's actually running 3 tasks in parallel. We'll talk about the modules one in a little bit. Again, that's covered in the Atlaskit 2017 presentation. Continuing, Webpack entry points. It's important to understand that these are components. This is code that's executed when your web resource is loaded. Things that aren't entry points are included transitively from your entry points. And in this case, in our plugin, any JavaScript file ending in .entry.js is defined to be an entry point, and everything that's not is included from that. And the idea is that the WRM Webpack plugin will generate XML fragments automatically for every single entry point you have and throw those into target, classes, meta-inf, plugin descriptors when you run the build. And those are picked up by the host application when your plugin is loaded. And if you add or remove these entry points, you'll need to reload your plugin because that's a new web resource and the product needs to understand that that exists. But if you're just changing the code in your existing entry point or adding additional JavaScript files that aren't entry points, you don't need to do a plugin reload. Webpack will automatically bundle those all into the same set of JavaScript files, pending that you're not doing some crazy code splitting. To get this to work, we're using the Atlassian WRM Webpack plugin. One snippet of this is showing us how we're saying to the WRM Webpack plugin, let's map an existing entry point into a specific web resource in our plugin XML. This is saying take the file admin.entry.js and give that a web resource key of Webpack admin resources. And if you're not loading your web resource into a specific context, make sure that this key is the same name that you have with the require resource in your velocity template. What does this look like? In our entry point, we first need to find a way to attach our page to the DOM. So the first thing we do is make sure our environment is set up. We're loading our polyfills, but be careful. We'll talk about polyfills in a little bit and some of the issues you might encounter. Next, we need to wait for the DOM ready event for when the page is loaded using the standard AJS.toInit. Technically, we should import that as a dependency as well, but it's also a global, so we're cheating here. Next, you find your mount point. So the React mount div that we rendered in our velocity template, we're finding here. And finally, we're rendering a React page tree. So we're rendering a page component from page.js, and then everything is magic React from there. Looking at page.js itself, you can see that we're using JSX. We've got a couple of components, Atlaskit, different HTML tags, and so on. And this is what it looks like. So we went through all of that configuration complexity to get this single one-page app. What do you do next? Well, go and build your code with React. From your page resource, go ahead and import Atlaskit components or other resources. You can include CSS within Webpack if you're not already using styled components, as well as images, and just import those as you would any other resource. And be careful, though, because as you add new images or CSS, you will require plugin reloads for those too, because they're served through the web resource manager in the host product. We'll talk about ways to work around that in a bit as well. Continuing, let's talk about working with some of our legacy code. All of your new code should be in Webpack, like I've said before. However, with minor changes, you can also call your legacy code from within your new Webpack code. And my opinion is not to try to do it the other way around. And you can think of this as what happens in Webpack stays in Webpack. Easy to remember here. So what do we do with legacy code? Your new code will all be typed. How do you access the old code from your new code? On the legacy side, you will create AMD modules if you don't already have them. And you'll be able to access that from your existing legacy code through standard AMD requires, and you'll be able to import them from your Webpack code. It's technically possible to go the other way around, but I don't recommend it. And you can also mix type check and non-type check code together if you really have to. You'll be working with Flow or possibly TypeScript and Atlaskit as well. Occasionally there's small problems like certain nested components aren't up to the latest standards with Flow. You can use your Flow config file, for example, to say that these classes are untyped. We're going to ignore them for the build because it's someone else's component anyway. And this works with other misbehaving node modules as well. We're also going to figure out how to work with global variables. Some Atlassian host apps publish global variables that you need to subscribe to or use in order to get things done and use those from new code. Let's look at that first. Suppose that we want to use ajs.i18n.getText. And I recognize this isn't actually a global variable, but it looks like one from the point of view of the type checker. So to make this work, we create a library definition in flowTyped that defines what is the shape of that object and what are the things we can call. And wouldn't it be nice, by the way, if Atlassian were to offer predefined library definitions for its own code that we could all import without having to reinvent the wheel every time. While we're calling globals, we're also using ESLint. We need to make sure that ESLint isn't going to throw errors when accessing this. Technically, we're cheating here. We're saying, if you see anything with AJS, ignore it and all of its components. In this case, we have Flow or possibly TypeScript checking that anyway, so we don't really care about ESLint in this case. Let's assume that you have legacy code that's not typed. So we've spoken about creating flow type definitions for them. How do we do that? This is some legacy code from the demo app. It's written as an AMD module that defines an adder function. There's not much there to it. Let's see how we can invoke that from our Webpack code. You see, we're adding a definition to the flow type directory. We're declaring an importable module and adding explicit types to its parameters. It's easy enough. Next, we're telling the WRM Webpack plugin how to get it. What this means is when I see import devdayapp 2019/legacy code, then load the web resource named legacy resources from our plugin XML, and then do an AMD require of devdayapp 2019/legacy code. That's not too bad, right? It's not very don't repeat yourself. Whoops, let's go back one slide. Let's talk about your legacy code typed. So what we did before wasn't too bad, but we can do better. We can ask Babel to automatically throw an ECMAScript module facade onto our existing sources, and then make that available to legacy code via AMD as well. What we can do is then take existing parts of legacy code without moving it into Webpack, and yet still add explicit type definitions to them. To do this, in the demo app, we've created a separate directory under source main resources modules. And we're telling Babel to transform every single JS file you see there into its own AMD module, which we can access from Webpack. And this is why we have 3 tasks running in parallel in the build script. We've got in resources/JS, we've got regular JavaScript compatible with your old AMPS build process with ES language level transforms. We've got resources modules, which will have everything magically transformed into an ES module. And in the front-end directory, we're going to Webpack everything. What does this look like? We're going to gently adjust the same adder function to make it a typed ES module, and that's in modules/legacy module.js. This will be exported as an AMD module via our gulp task. Next, we need to tell Flow, or TypeScript, how to find a specific import regular expression and map it to the right source files. So like magic, when you import devdayapp 2019/modules/foo from within the Webpack code, Flow will look for the module in the right place and automatically determine the correct types as well. You still need to tell Webpack how to load the resource, and that means you need to repeat the same provided dependencies logic from the Webpack config as we looked at in the previous slides. Let's talk about optimizing that dev loop a little bit. Now, images, you can import these within your Webpack code, but you have to do a plugin reload every time you want to add a new image. That's not very convenient. With this configuration, you can tell Webpack that anytime you see an image that's under 8 kilobytes in size, we're going to use a data URI to actually inline that inside your JavaScript. And what that means is that you can add or change images under 8K, and you don't need to do a full plugin reload to see the results. And as it turns out, most modern browsers support up to 2 megabytes of data URLs. So you could take that 8,192 and make it bigger, possibly consider doing different things for dev mode versus production mode. In addition, we can do something similar for CSS. So right now, by default, the CSS is served up as a separate file in a web resource by the Atlassian WRM. Instead, if you use this configuration, we can have your CSS dynamically inserted at runtime by your JavaScript into the page. You might not want to do this in production, but this will save you from having to do a lot of reloads in dev mode, although you should probably be using styled components anyway. Problems, our favorite topic. Now, making a major shift like this, we're certainly going to encounter some issues. The first one is, ooh, the host app bundles React. What do I do?
Certain hosts, such as Confluent Server 6.15, and I think certain recent versions of Bitbucket, also bundle React and React DOM as AMD modules. We want to use these where appropriate to reduce the page size. So how do we ship a single jar that works with both modern and legacy versions of Confluence? Well, what we do is we self-bundle React and React DOM as a library and ship a single jar for both host versions. We're going to create client JavaScript code that conditionally serves either the host or the bundled library. How do we do that? Well, we have a requirement on the host side where we generate a condition in our web resource that will check the host product version number and decide, are we new enough to have this bundled React? If so, we'll use it, and otherwise, we use the bundled version. You can see examples of this in the demo plugins Atlassian plugin XML under delegating React and delegating React DOM. And we have a special Webpack configuration to make this transparent to the client code as well, so that we can continue to use React resources by saying import star as React from React without referencing any special dev day app 2019/React references. In addition, let's talk about I18N. So internationalization, and particularly string localization, is a bit of an issue. I'm aware of 3 general approaches you can deal with that when working in this space, and each has its own benefits and drawbacks. The first one is to use ajs.i18n.getText, like you're used to in the server world already. This allows the WRM's JS I18N transformer to automatically inline translate your string keys into the appropriate language based on what the current user is using. This is seamless. It generates skinny JavaScript files, including only the strings you need, translated to the direct language you need. The drawback is that you need to re-implement this functionality yourself if you're using the same code to ship to cloud. Also, it goes to the Atlassian WRM, which means that you can't use the hot module reloading that was referenced in Atlas Camp 2018. One other approach is to use a separate I18N module. This was popularized by Andreas from Automation in the blog post titled Building a Jira Add-on Like It's 2016. In this case, you use a web resource data provider that dumps out every single I18N key for your app into something that can be consumed through a JavaScript module. And then you can send that module through the Atlassian WRM, and you can send everything else through the Webpack dev server. That's one option, and it's perhaps a really good approach if you have a single monolithic SPA. You don't mind getting all of your strings all in one place. But if you're writing an app that creates a tiny little web panel with one string, you don't want to be sending 500 kilobytes of I18N text either every time someone loads that. Another option is to use Webpack native I18N tools. In this case, this will bundle a separate copy of your entire app's JavaScript for each language that you support. So this has some advantages, some disadvantages too. This inflates the jar size because you're compressing multiple copies of exactly the same thing, but with different language strings. You also need to find a way to serve the strings dynamically based on user language, which you could do possibly from your velocity template, or you could try and do it client-side as well. This does work with Webpack Dev, though, so you can use hot module reloading. Summarizing that, we have these 3 different options that have various benefits and drawbacks. Last week, as this presentation was going to press, I heard from the front-end team at Atlassian that they're finding a way to put a check mark in that top right box, and I think that's probably going to be the way to go in the future. Other issues you might encounter: polyfills. The first issue is don't install twice. Certain host apps, such as Confluence, automatically include Babel polyfills in certain more recent versions. You need to make sure you don't try to reinstall it twice. And if you find it's installed, then don't install it again and hope that the base model, the base version of the polyfill that's included is sufficient for your needs. Be careful of globals you may create as well, because those have to be scoped to your app, and be particularly careful about third-party libraries and applications that may create globals without you knowing about them. And last, there are some other host product oddities you might need to be aware of once you move to a more modern build system. Like Confluence, if you use the fetch API, sometimes it will mutate your supposedly constant options object. Watch out for that. When you're building with Webpack, you also need to make sure in your Webpack configuration you specify a unique Webpack JSON pname in the options configuration. This in itself is another global variable that Webpack uses to load chunks. And if you have another vendor who's shipping an app on the same page as yours and these names collide, then you'll be in trouble. In addition, source maps. I went down all the way to the bottom of the rabbit hole with this, and I could not get it to work. So the Atlassian WRM plugin will try really hard to take pairs of JS and .map files and stream them together, throw them into context patches, remove all the line feeds, and adjust all the line numbers so it comes out right. Even when it did that, which was hard to get working, I found that Chrome sort of collapsed and died when it got a 60,000 line file with no carriage returns. So my advice is that working with non-source map JavaScript isn't too bad, so long as you're not using a lot of async or generators. It's actually reasonably readable. Other problems you might encounter. Styled components, version conflicts. You need to use version 3 of styled components, at least with the more recent versions of Atlaskit. What else? We can talk about ways we can make this build process and entire system a little bit better based on the demo app. First thing is, we can adjust the browsers list in the package.json. So for those of you who aren't familiar, this allows you to target the specific browsers that you want to use. I need to support IE 10 and up. Babel will automatically transpile your code down to the least common denominator. But as you drop support for older versions, you can increase those versions, and your code that you're shipping will get much closer to your actual source code. In addition, keep in mind that whether you're building for production mode or for dev mode, and this is controlled by the node-env environment variable through your POM. When you're building for React, node-env and production versus dev is important because you'll get the dev mode versus the production mode of React itself. This also controls minification and things like that. Next, make sure you commit package.json to your repository. This is a do as I say, not as I do in the demo app. This makes sure that your builds are deterministic. Other tools that you can use to make this build process better. Java flow, so some don't repeat yourself type definitions. If you have models coming down from the server in Java to JavaScript, you can automatically convert your Java objects into types for flow that will be automatically identical between the two. As far as testing, Jest and Enzyme are the state-of-the-art standards for React. I've used this myself. Jest output shows up as red in Maven, but otherwise doesn't blow the build, so it works fine. And there's a Jest Bamboo reporter as well, which works. Other things you can look at are flow coverage tools. This tells you how much of your code actually has type defs. You can also use the Webpack bundle analyzer that tells you of the 1 megabyte of output code that includes React and Atlaskit and other Atlaskit components, how much code is in a certain place in a nice visual manner, which is really helpful for optimizing build sizes. And other possible improvements, single-page apps. You can have multiple XWork actions pointing to the same code. You still need web items to render menu options on the host product, and they can all point to the same place, and you use client-side routing to determine what you actually render. And you'll also probably have to hijack the click handlers for those, but you can actually get it to work. In addition, you can look at doing async code loading for speed. And there were demonstrations of that in the Atlas Camp 2018 presentation. And that's all I have.
Thank you, Scott.
Looks like we've got 4 minutes or so for questions.
Yeah, sure. Does anyone have any questions? Or anyone embarking on any similar challenges? Yeah, I'll go on back here. And also think about some things that you might have cut in the interest of time.
Hi. You mentioned developing for both server and cloud at the same time. How do you manage serving your React code to the cloud, apps versus server, which is handled by Jira and WRM?
Got it. So in this particular case, this isn't being served to cloud. I think the previous session in this track went into a lot of the detail on how you actually go about including that in the build process. With this type of technology, you can write the same code, but your build on the cloud side will look a little bit different. You'll probably referencing the same code in the same place, but you would likely have your own Webpack configuration that's separate for cloud that would pull in those files from elsewhere and then distribute that however you would on the cloud side.
All right, thanks, David. Any other questions from anyone?
One up here.
Oh, all right, thank you.
So the testing of it, do you also do using the React tools like Jest or something?
What was the question? I'm sorry.
The testing of React components?
Yes.
How do you do it?
Jest and Enzyme are the state of the art.
And the same is used here as well as in
It's
this one?
not, that didn't make the cut for the demo app, but it
Okay.
can be included without a ton of effort.
Yeah, thanks.
Anyone? All right. Well, thank you very much, Scott.
Okay, thanks.